Good morning, and today's topic is minimization of DFA with example. In this, we use the minimization using the partitioning method, which is the mostly used method, and we have other method like minimizing the DFA, like table filling method. But here we concentrated only on the partition method. Suppose there is a DFA. DFA is a phi tuple notation, as we know. Q sigma delta Q naught F. Q indicates the set of states, and sigma indicates the input alphabet, delta transition function, Q naught is the initial state, F is the final set of final states. For that, we have to minimize the DFA. That means we have to design a DFA D dash such that here Q dash is definitely Q dash is subset of Q. Here Q dash is subset of Q, and F dash also maybe it is a subset of F. And for this, that means for the given DFA D, we have to construct a minimized DFA D dash, which is having less number of states when compared to the original DFA, and there may be a reduction in the final state also. Now let us see the procedure. The first point here is we will divide Q set of states into two sets. One set will contain all the final state, other set will contain all the non-final states. The partition and we call that partition as P naught, okay, and we initialize K to 1, and we find Pk by partitioning different sets of Pk minus 1, and while partitioning we check that whether Pk equal to Pk minus 1. If it is equal, then we stop the partitioning and we merge all the states in Pk to 1. Now let us see with these steps with an example. Here the question is how to find that two states in the partition Pk are distinguishable or not. Here two states, let us assume that Q and Qk are distinguishable in partition Pk for any input symbol A if delta of Qa, A and Qj, A are in different sets in the partition Pk minus 1. Now let us see this with an example. Okay, now we have to minimize this following DFA. In the first step, what it is written that here we divide this total set of states into two states. One set will contain the final state and other set will contain the non-final state, and we call it as P naught. That means here P naught is Q1, Q2, Q4 and Q naught, Q3, Q5, because what are the final states here? Q1, Q4, Q2. These are final states, and these are non-final states, Here we initialize K. Here K starts from 1, and we have to calculate P1. Okay, how we calculate P1? First take the states of the P naught. Here P naught is consisting of two sets. One is the set of final states and other is the set of non-final states. Here Q1, Q2, Q4 is the set of final states. Q0, Q3, Q5 is the set of non-final states. Here we are just simply checking like this: delta of Q1 on 0, it will lead to Q2. That means here Q1 on 0 means, what is the meaning? Q1 on 0 means delta of Q1 on 0, delta of Q2 on 0, delta of Q4 on 0. And we check this Q2. Here Q2 belongs to the, here we obtain for the Q1, Q2, Q4 we obtain the Q2. Here Q2 belongs to the set of final states, so we leave as it is. When compared with the one, here also Q5. Here Q5 is a non-final state, so we leave as it is. When we consider the non-final state Q0, Q3 and Q5, you can observe it from here. Delta of Q0 on 0 is Q3 and Q3 on 0 is Q1, and Q5 on 0 is Q5. Here if you observe Q3, Q0, Q5, these three states belongs to the same partition set Q3, Q0, Q5. And if you observe these three states Q1, Q4 and Q5, Q1, Q4 and Q5, here these two states belongs to final states in P0. Here Q5 is a non-final state in P0. So we should obtain these three states should belongs to this either final states or non-final states in the above preceding partition. Here P1, so we check for the P0. When we check for the P0, but there is some type of class, so we split these states. We split these states. Now we can see in order to calculate P2, here we P1 can be partitioned as these three. For this state there is no problem, so we maintained as this. But here in case of the Q0, Q3 and Q5, in the case of Q0, Q3 and Q5, we have to split. We have to make a split because Q0, Q3 and Q5 on one. Some are leading to the final states and some are leading to the one is leading to the non-final state. So we have to separate that final state and non-final state part. So Q0, Q3 we have partitioned into Q0, Q3 and Q5. In order to calculate P2, we check whether the partition sets can be whether the sets of the partition of P1 can be partitioned or not. Q1, Q2, Q4 on 0. Q2, that means here it is maintained as this. Here Q0, Q3 on 0. It is Q0, Q3 on 1. These are the non-final states. These are the non-final states of P1, and these are the final states of P1. Okay. And the Q5 itself is the non-final state, so we remain as this. That means that means we cannot partition P1 further. The partition of P2 will be Q1, Q2, Q4, Q0, Q3 and Q5, which is same as the P1. Now here PK equal to PK minus 1. Here P2 equal to P1. So we stop the partitioning process. After stopping the partitioning process, what are the states that are in the same partition? You merge it. Here Q1, Q2, Q4 are in the same partition, so we merged it. Q0, Q3, here they are in the same partition, we merged it. And this is the final minimized DFA, that we obtained. And the number of states in minimized DFA is the number of sets in P2. Here the number of sets in P2 is 3. So the number of states in minimized DFA is 3. Here two states QA and QJ are said to be distinguishable in the partition PK. For any input symbol, these two should goes to the same part. These two states should go to the same partition set in PK minus 1. Okay. If these two states do not go to the same partition set in the PK minus 1, then we can say that the two states are not participle if they are not going to the same partition set in PK minus 1. Now let us see. Now let us have this diagram. Here the final states are Q1, Q2 and Q4, and non-final states are Q0, Q3 and Q5. Now let us see. Here P0, initially we partition the all states Q2, two states. One is the final state and other is the non-final state. Here the final states are Q1, Q2, Q4, and non-final states are Q0, Q3 and Q5. And we initialize K21 for in order to find the partition 1 P1. First we check the states will be further partitioned or not. Suppose we take Q1, Q2, Q4, delta of Q1 on 0. Similarly, delta of Q2 on 0, delta of Q4 on 0 leads to Q2. Similarly, delta of Q1 on 1, Q2 on 1 and Q4 on 1 leads to Q5. Similarly, that means they are going to all these three states are going to the same state Q2. That means the Q2, which is in the final state partition. So no problem. Here when we consider the Q0, Q3 and Q5 on 0, then they are going to then all these are going to the same Q0, Q3, Q5, which is a non-final state. That means all the states that are in one set are going to the same partition of the preceding set of P0, preceding set, that is P0. Here on one it is like, then here on one we get two different types of states. Here Q1 and Q4 are the final states and Q5 is the non-final state. So we have to partition these Q0, Q3 as one partition and Q5 as one partition, and we check. That means the partition of P1 will be like this: Q1, Q2, Q4, Q0, Q3 and Q5, and we check Q1, Q2, Q4, Q0, Q3 and Q5 can be further partitioned or not. Here in this example, we cannot further partition these states. We cannot further partition these states. That means here we get the answer P2 same as the P1. Here we get the P2 same as the P1. And you can observe the algorithm stop when. That means we have to when to stop the partition. We can stop the partition when Pk equal to Pk minus 1. Here we get P2 equal to P1. So we can stop the partition. Now all the states that are in the same partition set can be merged. Now all the sets in same partition set can be merged. And the number of states in the minimized DFA are the number of sets in the partition Pk. Here partition is P2. Here P2 is having three different sets. So number of states for the minimized DFA is 3. Here Q1, Q2, Q4, these are merged to the single state. And the final DFA is this thing. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.